This video goes over the concepts of reliability and validity in biostatistics. Reliability is the degree to which an assessment tool produces stable and consistent results, while validity refers to the accuracy of an assessment and whether or not it measures what it is supposed to measure. These sound like they might be very similar at first, but they're actually very different concepts. We're going to go over each of these concepts more in depth and learn more about the different types of reliability and validity and see how they're different and also how they work together. So first, let's start with reliability. There are 4 different types of reliability. I'm going to go over each of these types and then we'll talk about them one by one in more depth with some more specific examples. So first we have inter-rater reliability. With inter-rater reliability, we're looking for a measurement to be consistent when different people are taking it. So for example, we have 2 customers taking different satisfaction surveys. We have customer 1 and we have customer 2. And the results that they get should be somewhat consistent. So with different people taking the same form of an exam or a survey, they should get similar results. Not that the people's answers will be exactly the same, but you're not going to get wildly different results because people understand the questions differently or things of that nature. So next we have TEST-RETEST reliability. With TEST-RETEST reliability, we're looking for the measurement to be consistent at different time points. So we have the same person who takes the test at time point 1 and time point 2, and their answers should be somewhat consistent. This is a very common type of intervention that's used in social sciences where you give a test, you give an intervention, and then you do a retest to see if there's an increase in knowledge or a difference in attitudes after the intervention. It's called a pre-test, post-test type of intervention study, and we want the results to be different because of the intervention, not just because the measurement tool or the test we're using is not reliable. So every time people take it, they get wildly different results. It needs to have some consistency so we can make some conclusions about whether or not the differences being seen are because of the intervention that took place. The next form of reliability is parallel forms reliability. So for this version, we have different versions of the same survey or test, and different people are taking different versions, and the answers and the results we get should be somewhat consistent from version to version. An example would be the SAT. There are many different versions of the SAT in circulation at any given point in time. There are so many students around the United States that take the SAT that they vary the versions. But the results should be consistent. You shouldn't take one version of an SAT and get a 1600 and another version and get a 900. There will be some differences just due to the questions being different, but the test should be mostly reliable and produce consistent results, whether it's a version A or a version B that the person is taking. The next one we're looking at is internal consistency reliability. I think this one's the most confusing to understand at first, but basically we're asking about constructs or attributes, and we want those to be consistent within the test. So we might have multiple questions asking about the same construct or attribute, and we want all of the questions about attribute 1 to be consistent with each other. So you see this a lot on diagnostic type tests, and we'll have a more specific example in just a moment. So with TEST-RETEST reliability, we're looking at whether or not the measurement tool gives the same results, or at least consistent results. It should be stable over time. As an example, we have 26 patients that are given the Beck Depression Inventory Test on 2 separate occasions. If our test has high TEST-RETEST reliability, there'll be a strong correlation between the results, unless there's been some intervention or change that has taken place in the interim. So we sometimes are going to use pre-test and post-test as a way to measure the efficacy of our intervention. This is very common in psychology and also in social sciences. If our test has high TEST-RETEST reliability, we can give the test, we can do an intervention, then we can give the test again, and we can say that any differences that we see from time point 1 to time point 2 in our pre and post test, any differences are going to be due to our intervention rather than to the test variation. Parallel forms reliability, we have different versions of the same assessment tool. So just like I was using the example with the SATs, we had version A and version B, and those should give you consistent results. Think about using different measuring tapes. If you're going to measure the same person with different measuring tapes, you would expect to get pretty much the same result. Your height's not going to be vastly different because you use a different tape measure. So the tape measure has to have parallel forms. Tape measures are going to be consistent unless there's something wrong with manufacturing. The tape measure is going to be consistent, and different tape measures are going to produce the same results. We're going to use parallel forms reliability to develop new tests. When they're trying to develop new tests like the SAT, they would create a new version of the test, and then they would pilot test that along with an accepted version of the test. So we want to make sure that our new versions have consistent results. With internal consistency reliability, we're measuring the internal reliability between test items that measure the same construct. A construct is a group of ideas. So we want to get at the construct of impulsiveness. And on this ADHD test, we have the following questions. I often have trouble waiting my turn, and I often interrupt others. These are different questions that are going to be mixed up at different time points in the test that the person has taken. They're measuring the same construct, which would be impulsivity. So we would have maybe 5 or 6 different questions throughout the test that are measuring this same idea, and you look within the test to see if those are being consistent. So when you're measuring a diagnostic test, frequently the person has to score a certain number on each of the constructs. And so for an example here, the construct was impulsivity, and we mixed up those questions and asked it different ways to see if there's consistency. Again, this is very common with diagnostic tests, so you would see this for a diagnostic test for mental conditions, looking for depression or looking for bipolar, and then again for things like ADHD, very common to ask the same question in different ways throughout the test and then look for consistency between those answers. With inter-rater reliability, different interviewers using the same measurement should get same or similar results. It's basically a measurement of agreement. A very common method for doing research in social sciences is to videotape interactions. And if I'm studying mother-child interactions and trying to measure attachment level, I might videotape the interactions of mothers and children, and then I would go back later and code those interactions according to a sheet that I had developed. So I'm going to look for specific things that happen in that interaction and then determine whether or not they have a high, medium, or a low level of attachment to the parent. And you want to have a healthy attachment to the parent, so the child will come and do things with the parent, but also is not afraid to leave the parent and be independent. Overly attached children is a sign of unstable relationship. So with the inter-rater reliability, my coding sheet would have high inter-rater reliability if different observers would watch the same interaction and they would have the same result. So frequently when you do this type of social science and you're coding interactions from videotapes, or if you're looking at records and pulling out information and coding it, you would have 2 observers who are doing the codings independently, and then they would compare results, because you want to make sure that what you're seeing is not just a variation due to one person's opinion, and you want to make sure that your coding sheet is reliable. So 2 different people would simultaneously do the coding and then compare results, and if there were areas where they disagreed, then they would sit down and go over those, or have a third person that would arbitrate differences. But the basic premise here is that my test that I'm using and my coding sheet that I'm using should be reliable in that different people using it will get will get the same results. So how reliability works. This table shows you the different types of reliability and when you might want to use it, as well as how you would figure that out. So for most of these, I'm looking at correlation. A correlation is the relationship between 2 variables. A correlation is measured on a scale between 0 to 1, with 1 being a perfect relationship. They're basically, well, they are the same. They're exactly the same if it's a 1, which you almost never see. So between 0 and 1, I'll have a correlation that tells me how similar these items are. And with test-retest reliability, parallel forms reliability, and internal consistency reliability, I'm using correlations or looking at the relationship between the two items to assess how consistent they are. With inter-rater reliability, this is a little bit different, and with inter-rater reliability, I'm looking for the percent of agreement between the raters. So like I mentioned with that example, you have two different people who are doing the observations. They're going to compare once they're done with the observations to see which ones they agree on and which ones they disagree on. So I would look at the percent of agreement between the two different observers. And if I have a high percent agreement, meaning that they have the same results for almost all of the observations, I'm going to conclude that I have high inter-rater reliability. So a reliability coefficient will be positive. It'll be on a scale of 0 to 1.0. Or I should say, yeah, 0 to 1.0 works. The general rules of thumb that we're looking for test-retest high reliability, we would consider that between 0.6 and 0.1 or 1.0. For inter-rater reliability, we're looking for 85% agreement or better. For internal consistency, we're looking for 0.7 to 1.0. But note that high reliability does not mean quality. It just means that it's consistent. And this is where we'll get into the difference between reliability and validity. Reliability is looking at the consistency of a measure over time. And when we get into validity, we'll see that validity is looking at the quality or the accuracy of that measure. So how can we establish reliability? Well, we want to make sure that our instructions are standardized across all the settings. So if we have a survey that's being administered, if people are administering it door to door, for example, I was part of a survey where we went out to assess the effect of heat events in different parts of Maricopa County, and we had a script that we had to follow. You feel a little silly reading from a script, but you want to make sure that people are getting the same instructions and that different people administering the same survey are doing it in the same way. And one way to do that is to have a script that people will read. The script, rather, that the people who are administering the survey will read to the participants. Or if you have written instructions that the people can read those themselves, those would be standardized across all settings as well. As needed, you could increase the number of items or observations to make sure that you have enough observations to look for the internal consistency between those constructs. You definitely want to delete any unclear items. And one way to find items that are unclear if you're developing a survey is to pilot that. Have a small group of people take it first, even if it's just friends and family. You might think that a question is perfectly clear, and then somebody else reads it, and with their different background, maybe different cultural background that they come from, they read that question entirely differently, and it's not how you intended it. So doing a small pilot study of your instrument first can help you catch any of those areas where things might be unclear, and you can either clarify it or delete it. Once you see with the different versions of a test how people are doing on those, you can adjust the easiness or difficulty. Maybe one version of a test is a lot more difficult than the other, so you would mix up questions and you would make that so that it's more or less even. And then the last thing here is to minimize the effect of external events. So imagine that you're taking the SAT test and there is construction going on outside. There's jackhammer, there's all kinds of noise outside. That's going to really affect your ability to concentrate on the test. Also, imagine you're taking that same test and it's in June in Phoenix and the air conditioner is not working. Okay, it's going to be 120 degrees in that room, or at least feel like it, and that's going to make it a lot more difficult to concentrate on the test as well. So when you're administering a study, a test, a survey, any sort of intervention, you want to minimize the effect of external events such as temperature, noise, things like that that are going to influence people's performance. You want the results you're seeing to be because of the intervention that you're doing or what you're trying to study rather than external events. So think through those and minimize those as much as possible. So now let's get into validity. And here's the difference between validity and reliability. Validity is looking at whether or not the test measures what it is supposed to measure. We want to make sure that the test is appropriate, meaningful, and useful. We have 3 different types of validity. These are content, criterion, and then within criterion we have predictive and concurrent, and then also construct validity. So we're going to talk about examples for each of these and how you might measure them. So content validity is how well the assessment taps into the various aspects of the construct that's measuring. Remember, we said a construct is an idea that's grouped together. A construct is an idea that we're trying to measure, such as impulsivity. So with validity, we want to see, does it really measure the construct it's supposed to be measuring? With reliability, we were only concerned with whether the answers were consistent within each construct. We weren't concerned with whether or not that construct was actually being measured appropriately, just that the answers were consistent. However, with content validity, we're looking at whether it really measures what it's supposed to. And we're going to establish content validity with content experts. So we have Business Cat here. Business Cat is a content expert, and he can help us determine content validity. As an example, a content of SAT tests would be evaluated by committees of experts. When they're trying to develop new SAT tests or new AP tests, they have committees that are comprised of subject matter experts that are going to help to create the questions and to develop those tests. Criterion validity assesses whether a test reflects a set of abilities in current or future setting. We can have concurrent validity, which is looking at current measures. So this is looking at how well does my test correlate with outcomes of a similar test right now. And we have predictive validity, which is looking at how well does my test predict performance on a similar measure in the future. So the keywords here are concurrent and predictive. If we're looking to correlate with a measurement that's happening right now, that's going to be concurrent. And if we're looking to somehow predict performance or look at something in the future, that's going to be predictive validity. As an example, the SAT measures academic achievement and future success in college. If we wanted to look at the concurrent validity of the SAT, we could look at the correlation to the ACT score. So the same student is going to take the SAT and the ACT. For criterion validity, if we looked for concurrent validity, there should be some correlation between those two measurements. Obviously, they're measuring slightly different things, and so there will be some variation, but there should be a correlation between the two scores. For predictive validity, we could look at the correlation to the freshman GPA. So does the SAT predict how somebody will do in college, and can it predict the freshman GPA? So we would look at correlation. Concurrent validity, again, is looking at a current measurement, and predictive validity is looking to predict a future measurement. Construct validity is a very interesting idea, but it's fairly difficult to establish. So remember, a construct is a group of interrelated variables that are measuring a concept or an idea. Some examples are aggression, hope, intelligence, and we had the example earlier of impulsivity. So you want your construct to correlate with related behaviors and not correlate with unrelated behaviors. So here's an example. Researchers want to assess overall happiness. They ask participants to rate the following questions on a scale of 1 to 5. I am happy during the day. I feel valued in my professional life. Is this measuring overall happiness? Think about that for a moment. Well, let's look at the questions a little bit closer. The first question, I am happy during the day. The second question, I feel valued in my professional life. Both these questions are asking about happiness during working hours, and so they really could be measuring job satisfaction instead of overall happiness. Maybe there's a person that doesn't like their boss or doesn't like other aspects of their job, but they do like their family and they do like their neighborhood and they do like their extracurricular activities. So overall, they're fairly happy, yet they have low levels of job satisfaction. The way we're asking these questions, we might actually be measuring job satisfaction instead of overall happiness. So this table shows you the different types of validity, when you might want to use it, and how you would use it. So for content validity, remember we're going to use a content expert. We're going to use Business Cat. He's our content expert, and he's going to help us determine content validity. With criterion validity and with construct validity, we're going to use a correlation. So we're going to correlate the scores from a test or other measure. And remember, this can be concurrent or predictive. And then for construct validity, we're going to see how well our scores correlate with an already established outcome for the construct that we're trying to test. So we want to look at depression. We'll have underlying constructs such as hope and sadness, and our answers we would on our test we would correlate with an already accepted scale for those items. Okay, a little bit of practice. We have a few scenarios here to get you thinking about reliability and validity. So here's a scenario. You step on your bathroom scale. It reads 117 pounds. You step off the scale and back on. It reads 143 pounds. You step off the scale and back on. It reads 108 pounds. Okay, so think about this for a moment. Is the scale reliable? No, this is not reliable. Reliability is concerned with consistent measurements, and these measurements are not consistent. I can't imagine there's something happening that would actually explain these results, so the scale is not reliable. Is the scale valid? Well, valid, we want an accurate measurement, and this can't be valid because our results are so vastly different that those three cannot all be accurate. So in this case, the scale is not reliable or valid. Okay, we want to assess the IQ of first graders. Since many of them can't read well, you develop a test that shows the subject a series of pictures. Later in the test, participants are asked to recall the series of pictures. Is this test reliable? Well, reliability would be concerned with the consistency of results, and so as long as we have consistency of results, yes, this could be reliable. It seems like based on the information we have, it would be a reliable test. Is the test valid? So is the test measuring what we really want it to measure? Well, we want to measure IQ, and we're showing a series of pictures and asking them to recall the pictures. So what we might actually be measuring instead of IQ is actually memory. How well can they remember a series of pictures, which is not necessarily the same as IQ. So in this case, we're probably not testing what we want to test, and the test would not be valid. So in summary, reliability and validity are different but similar concepts. They're related to each other. Reliability refers to the consistency or stability of scores, and validity refers to the accuracy that we can make interpretations from those scores. So reliability equals consistency, validity equals accuracy. So here's how we would determine reliability or validity. We would use expert opinion for content validity. We would look at the percent agreement between different observers or raters for inter-rater reliability. And we would use a correlation for test-retest, internal consistency, parallel forms, criterion validity, and construct validity. Some things to remember about reliability and validity. A test can be reliable but not valid. So we could get consistent results that are consistently wrong. But a test cannot be valid unless it's reliable. So think about it this way. A test cannot do what it is supposed to do unless it can do what it is supposed to do consistently. So we have to have consistency before we can have a test that is accurate. But on the other hand, we can have a test that is reliably inaccurate. We could have a scale that is 10 pounds off, but it tells the measurement 10 pounds off every time. So that scale is actually reliable, but it is not valid because it's not an accurate result. So here's another way that we can conceptualize this. We can have something that's reliable but not valid. So we're hitting the same point every time, but it's not the mark we want. We can have something that's reliable and valid, so we're consistently hitting the middle of the target, which is the spot we want. And we can have something that is unreliable and then not valid, so that's all over the place, and none of those are what we're actually trying to measure. Okay, so think about it and see if there's any points that stick out to you or that you're confused about. You can watch back through this recording and see if it helps clear it up. Here's also some additional resources for helping you to understand reliability and validity, and also for calculating reliability and validity. I hope this video helped clear up the concepts of reliability and validity, and you can see how we need to have both consistent and accurate measurements in social sciences.